Hello guys, today we are gonna learn about quadratic functions going from standard form to factored form. This is again a brief introduction into all of this. So just a quick review. A quadratic function is also called a parabola. We learned this the other day. And a parabola is usually shaped as a U, so it's either opening up or it's opening down. And a quadratic function has a set form. In this form, it's going to be our function equals ax squared plus bx plus c. This is very similar to what we see with linear standard form. In the past, we've worked with, for example, ax plus by equals c for linear. And then we've also worked with exponential, which is y equals a times b to the x. So again, this is just another standard form for a quadratic. What makes this a quadratic is the x squared. A quadratic has a degree of 2. Again, there's that vocab we learned the other day with degree. The highest exponent is 2. So therefore, a quadratic always has the term ax squared. A, b, and c are just representing numbers here. So we have the standard form, and we're going to convert it into factored form. For factored form, again, this is going to look really fancy, but it's not hard at all. For factored form, we're going to have ax minus b times cx minus d. Again, we're putting different letters here because a could be a different letter from b, c, and d. They could all just be different. We have worked with these type of expressions when we were multiplying polynomials. So if I go back to one of the lessons we did, here we multiplied x minus 3 and x minus 1, which is our factored form. Back then we weren't calling it a quadratic. And then we got it into standard form. So again, we did this multiplying with the box method. Now we're going to start with the standard form and go into factored form. Let's review factoring real quick though. So if I were you guys, I would write down the title Factoring Quadratics, because we're going to factor the standard form of a quadratic. And then factoring means to break down into simpler terms. Okay, so let's just review real quick what factoring means to us. For example, if I give you 100 and I told you to factor that down, we learned how to do a factor tree. We would say what two numbers multiplied at 100, that would be 50 and 2. And then we would try to break that down even more. The 50 breaks down to 2 and 25. And the 25 breaks down into 5 and 5. Because all of these multiply to give us 25 and then 50 and then 100. So therefore, here are our factors. And we know that 2 times 2 times 5 gives us 100. So we broke down 100 into something with smaller numbers that we can work with. Here we're going to be doing the exact same thing, but we're going to be doing it with expressions. And I know it looks intimidating, but just learning some quick strategies will help us along the way. So that's kind of like how factoring is, breaking it down into simpler terms. We've done it with numbers, now we're going to do it with expressions. So let's go ahead and review one skill real quick. I had taught you guys how to do the box method, multiplying polynomials. So for example, if I gave you x plus 3, x plus 3 times x plus 8. Let's say I want to multiply those two. Notice that those are our factors, x plus 3 and x plus 8. And to multiply them out, I use the box method because that's what I like. So the x up here, the 3 here, x, 8. We put each one on each side, and we said x times x is x squared. 3 times x is 3x. 8 times x is 8x, and 8 times 3 is 24. And then we said these two are like terms, so I can add them and get 11x because we're adding everything in the boxes. So from here, today we're not going to talk about zeros, so don't worry about the word zeros, roots, or solutions. So here we have the standard form of a quadratic. So standard. And our standard form is going to be x squared plus 11x plus 24. So we went from factored form to standard form, like that. And that's what we have to use in order to undo the standard form into factored form. So let's go ahead and try an example down here. Again, pause the video, guys, rewind to anything I said, email me, let me know if you have questions. So here we're starting with our function, which is in standard form, and we're asked to find the factors. After you do the box method so many times, you know that the x squared goes here, the 12 goes down here, and whatever goes here in the middle has to give us that middle term, 13x. And remember, you add these to give us 13x. So let's do this. We know that to get this x squared, the only way we can do that is if we have an x here and an x here, because x times x gives us x squared. That's the easiest part, always. Now, the tricky part. We have to find what goes with that x and what goes with that x. These x's have to multiply to 12, and they have to add to 13. Because we have to add those two like terms to get 13, and then in that bottom box, we always got it by multiplying. So one of my suggestions to doing this is list all the factors of 12 that multiply to it. So 1 times 12, 2 times 12. Notice that I'm going in order. I started with 1. Don't ever forget about that 1. And it's not 2 times 12. It's 2 times 6. My mistake. So 1 times 12 gives us 12. 2 times 6 gives us 12. The next one to follow would be 3. 3 times 4 gives us 12. And then after 3 is 4, but we already have 4 up there. So we're done making the list of the factors of 12. So out of these, we have to see which one adds to 13. 2 and 6 does not add to 13. 3 and 4 does not add to 13. So our answer is 1 and 12. What are the numbers that satisfy this? 1 and 12. So we got 12x here. We got 1x there. 1x plus 12x is 13x. So in the end, how did we find our factors? Here they are. X plus 1, x plus 12. And there we go. There's our answer. So let's go ahead and try another one. Why don't you try it on your own? Pause the video, rewind the example I did so that you could understand how to do it, and let's do it. So make sure you pause the video and try the next example. Alright, so I hope you pause the video now. Here, again, we start with the standard form and we're trying to find the factor form. We've discovered using the box method that x squared typically goes there, 40 goes here, and whatever those two terms are have to give us 14x. And the easiest part always is that we know x times x gives us x squared, so that's nice and easy. Now, we have to find two numbers that multiply to 40. I'm just going to write the letter m instead of multiply. Multiply to 40 and add to 14. And let's start with our factors of 40. So I'm going to make the list. 1 and 40. Don't forget to start with the 1. Then 2. 2 times what gives us 40? 23. 3 times, nothing times 3 gives us 40. So 3 doesn't work. 4 and 10 work. 5 and 8 works. So again, all these pairs multiply to 40. Then after 5, we got 6. 6 does not work. There's no number times 6. That gives us 40. 7. 7 does not work. There's no number times 7. That gives us 40. And then we're back at 8. And 8's already on our list. So it can only go up from there. And we already have all those possible combinations. So that's it. That's all my numbers that multiply to 40. Now that we've satisfied that requirement, we're going to move on to the next one. 14x. It has to add 1 and 40 will never give me 14. 2 and 20 won't give me 14. However, 4 and 10 will. So put a 4 there and a 10 there. I get x plus 10 and x plus 4. Alright. So those were very simple because they had a plus on there. It was just plus plus. A little bit more difficult is the negative one. This one requires us to do a little bit more thinking. The only way you're going to get better at this is to practice. So I'm going to try to explain my thinking. You may approach it various ways. You don't have to think exactly like I do. So let's go ahead and try the next one. So again, we have this quadratic in standard form. So we got x squared, 28, and negative 11x, because we're filling it into the box and we want to fill out all the other pieces. And so again, I'm going to start with the easiest part, x times x. Now, this one is trickier because we have a positive 28, and this is a negative 11. I'm going to do this kind of just by guess and check first, because that's one of the ways that students seem to be most successful until they start seeing patterns. So I'm going to start the same way I did with the other one, where it multiplies to 28 and it adds to negative 11. So I'm going to put all my multiples of 28. 1 and 28, 2 and 14. You do have to use a calculator for this. Again, this is a skill that doesn't come easily. The more you practice, the better. 3 does not work. 4 and 7, 5 does not work, 6 does not work, and 7 is repeating it all over again. So those are all my factors. Notice that none of these, they do. 4 and 7, 4 plus 7 gives me 11. So I'm close. I need 11, but I don't just need positive 11, I need negative 11. So I'm very close. 1 and 28 and 2 and 14 does not work. So here, let's think about this. We need a positive 28. The only way to get a positive 28 is if they're both positive. But if they're both positive, they can't give me a negative 11, so that doesn't work. Again, rewind the video because I say a lot of information. So make sure you know. So if they can't both be positive, let's try both of them negative. A negative times a negative gives me a positive 28. A negative 4 plus a negative 7 gives me a negative 11. So they're both negative 4 and negative 7. Because a negative 7x and a negative 4x give me that negative 11x. And the negative times the negative is a positive 28. Again, how did I know that? I've done a lot of these. I've had to play around with my positives and negatives. So make sure that when you do this, you remember that you need positives and negatives. So hopefully that worked out for you guys. Watch the next video where I do some more examples with positives and negatives. But again, this is a skill that you got to practice. Rewind the video, try them again, then watch how I do it. Let me know if you need some more practice, watch some more videos. And good luck, guys. We're going to continue factoring some more in the next video, so make sure you watch that. Have a great day.